Let's have a look now at graphing linear functions, and I've put together a series of examples. So, and I might spread these over a number of videos, in fact. But let's have a look at the first one, which is just graphing a couple of linear functions. Okay, so example 1, part A, is to graph the linear function y equals 2x minus 1. And then from the graph, determine the gradient and the y-intercept. And part B is another linear function, but in a different form. This one is graph the linear function 3x plus y minus 2 equals 0 by first rearranging the formula into the form y equals mx plus c. Okay, so let's go back to the first one. Now I'm going to graph these two different ways, in fact. So for part A, I'm going to use the table of values method. Okay, so there's no really right or wrong method as long as it produces the end result, right? So whatever you feel most comfortable with, graph it the way you feel best. Otherwise, if the question does ask for the line to be graphed a particular way, like for example filling in a table of values, then by all means, answer the question if you want to get all the marks, and answer it the way it asks you to answer it. So what we'll do is let's do a table of values first. Okay, so I'm going to make this a little bit harder than what you'd normally expect, because I'm not giving you the table of values with predetermined x values. Okay, a lot of the table of values that you might get would have x values that are already determined for you. So what we're going to do first is we're going to determine the x values, and then we'll calculate the y values from those. Okay, so I guess a force of habit, if I'm asked to sort of graph a linear function, a line, you need 2 points as a minimum. But it's kind of nice to have more than 2, just in case you make a mistake with one of the points. One of the, I guess, characteristics of a line is that all the points, okay, and these form coordinate pairs, all the points have to line up. They all have to basically sit on the line. And if one of the points is off the line, then one of your calculations is incorrect. One of your coordinates is incorrect. So I usually like to have for the x and y values, I like to have basically 5 of each. And the middle one, I like to make that an x value of 0. And I like to have a couple of positive x values and a couple of negative x values. Okay. Now, it doesn't really matter which values of x you pick, in fact, as long as they're reasonable. Okay, don't pick 2,000 or something. I would probably maybe actually based on the function 2x minus 1, I might maybe go, say for example 3 and maybe 6. Okay, for the positive values, and they don't even have to go up in a set order. Even it can be 5 random numbers. It really doesn't matter as long as they're reasonable choices. You'll see what I mean by reasonable later. Okay, so I'll go -3 and -6. So 5 values. I probably wouldn't need all 5. 3 values would probably be another good number to a good number of coordinates to use. Anyways, so this is our function, our linear function, y equals 2x minus 1. All right, I've got the calculator ready. Okay, and I might just brighten the camera a little bit there. Right, I always just start off with the 0 because that's the easy one. You substitute in these values into the equation and you work out the y values one by one. Starting off with 0. When x equals 0, that's the independent variable if you recall, what's the y value? So 2 times 0 minus 1, okay, 2 times 0, right? 0 times tables are awesome, right? It's always 0, isn't it? So that's going to be -1. So this is in fact a coordinate. This is the coordinate 0, -1. Okay, that's how you read it. You read it basically down the column. Each column is a coordinate pair. Okay, so let's fill out the rest. Okay, so when x is equal to 3, 2 times 3 is 6, 6 minus 1 is 5. Okay, what about when x equals 6? 2 times 6 is 12, 12 minus 1 is 11. Notice that the x values are all going up by a set amount, by 3. The y values are going up by 6. That's what the gradient is. In fact, that's exactly what the gradient is. It's the rate of change of y compared to x, right? So as x is going up by a set amount, y is in fact going up by double that amount. That's why this 2 is there. All right, so it describes what is happening to y. Likewise, back the other way. So when x is -3, -6 minus 1 is -7. That makes sense because going back the other way, if you're subtracting 6 from all these values, it's exactly for the same reason. As the x values go downwards, the y values also go downwards, but by double the amount each time. Subtracting another 6 again, that should be -13. And that would make sense. 2 times -6 is -12, minus 1 is -13. Now we have 5 coordinates, or 5 points, and their coordinate pairs. So let's use some graph paper now. Okay, so I might just, hopefully you can see that okay. Yep. All right. What I'll do first is I'll plot the points. Now, you need one of these, all right? Pencil. Very handy. You make a mistake, you can rub it out. Notice that I've drawn the axes. I've used red pen, but probably best to use black pen or blue pen. Only reason why I use that, so it just appears, stands out a bit more. And with pencil, if you make a mistake, you can rub it out, you can start again, okay? So I know a lot of people might have a sort of a tendency to automatically use pen. Just stop for a moment, make sure you've got, a couple of pencils there handy. All right, let's start with, doesn't matter which order, 0, -1. Oh, by the way, what do you think this is? This point here. Okay, this 0, -1. Now, if you said y-intercept, well done to you. All right, so 0, -1. Okay, I didn't put numbers on the axes, but just assume that they go up by ones. Okay, so that would be 1 point there. I like to put like an X, sort of an X marks the spot. Just makes it just a bit easier to see the point. If you just put a little dot, you'll probably miss that. Okay, all right, 3, 5. Okay, so that's another coordinate pair. I might just write this one here. So that's 3, 5. All right, and that goes, so you go 1, 2, 3, 1, 2, 3, 4, 5. You got one there. Okay, 6, 11. Okay, sorry, I'm taking my time with this because I really need you to see how this is done. Okay, take your time with it. There are quite a few marks attached to drawing graphs. Okay, so while it might appear tedious, they're not difficult at all. Okay, so just take it as, here's an opportunity for some easy marks. Anyway, enough talk. So that's 3, 4, 5, 6, and we're going to go up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. By now, you can probably see that there's definitely a line forming there. All right, and just to complete the picture, let's plot the other 2 points: -3, -7. 1, 2, 3. That's -3, -1, -2, -3, -4, -5, -6, -7. Okay. And -6, -13. Okay, so -4, -5, -6. Okay, there's -7, -8, -9, -10, -11, -12, -13. Right, now if you've done this correctly, all right, just move that out of the way. The points should line up. Okay, so now the points might be ever so slightly off, and I don't think that's a drama, as long as you're pretty close. All right, you can tell if you're pretty close or not. So okay, I'm going to darken it a little bit. Okay, you can do it very lightly in pencil if you like, and then just go over it in pen if you're happy with it. All right, and notice that the axes are labeled as well. Whoops, I'll just straighten that out. Notice that the axes are labeled. Okay, X, Y, and origin. Okay, another good habit to get into is to label a couple of the points with the coordinates. Okay, especially if there's no actual markings on the axis itself. So I might just label the might be a bit difficult here, but I might just label this one here. This point, this is the point 3, 5. And I might just label this point here because it's convenient, 6, 11. Okay, in doing so, it makes it very clear that you've located the line correctly, and I can tell just from these two numbers, in fact, that this is in fact the correct line. All right, correct gradient and correct y-intercept as well. Even if you haven't labeled it, I know from these two numbers, in fact, as a marker, marking any of these sort of questions, that this is the correct line. Let's have a look at the next one now. Right. Graph the linear function 3x plus y minus 2 equals 0. But firstly, we need to rearrange this formula. This is not in the form y equals mx plus c. What are you going to do about that? You're going to say, I need to rearrange it because this is not a form that I'm familiar with. Well, let's turn it into a form that we're familiar with. And this is where you've got to switch on your, or should I say, put on your algebra cap and say, well, okay, switch on the algebra part of your brain. And let's start off. All right, let's start off with the original formula. So 3x plus y minus 2 equals 0. Looks a bit sort of strange. What does that mean? Y equals mx plus c. We just want the y on one side. Well, what's 3x and minus 2 doing there? Right, shoo, go away, right? Go to the other side, I don't want you there, right? So we want to kick the 3x and the negative 2 poof, over the other side, all right? Past the equal sign, kind of like a bit of a boundary, isn't it? To move it over, leaving the y where it is. Okay, 0 is a nice number because it indicates there's nothing there. It's almost like it's blank. 0 means there's nothing. All right, let's move the 3x over. When you move it over, it becomes the opposite sign of what it is. So if that's positive 3x, when you move it over, it becomes negative 3x. The negative 2, when you move that over, when you sort of kick it over to the other side, it becomes a positive 2. Okay, very simple. Now you can use whichever method you like, backtracking, balancing method, whatever you like to do with equations. So hopefully if you're familiar enough with equations, this is not hard at all. In fact, this should hopefully be second nature to you. All right, we now have our equation. And just to make it look nice and neat, and I'll just write it like that. Right, looks a bit like the last one, doesn't it? This time around, I'm not going to use the table of values. I'm going to show you a slightly different way of doing this. You can draw it directly on the graph itself. How? Let's see. Just bring the graph paper back. Okay, so this is, right, this one here. So I'll just move that to the middle now. Okay, and that's 3x plus y minus 2. And we ended up rearranging this formula to y equals negative 3x plus 2. Okay, so I just need to write that down. So how are we going to do this without a table of values, you might say? Well, there's something that we know already, or there's two things we know. We know the gradient's negative 3. What's that? A downhill or an uphill level, or is it a vertical? Negative 3, downhill. Right, from left, always from left to right. Okay, so it's going to go down this way, isn't it? And we've got plus 2 for the y-intercept. Now, that's one point you already know. The y-intercept, no surprises, lies on the y-axis. Okay, so, and that's going to be at the point 0, positive 2. 1, 2. There you go. Nice sort of X marks the spot there. Might just zoom in a little bit on that. That's better. All right. Okay, maybe just put the equation there so you can see that. Okay. Right. What does this gradient mean? This gradient, the gradient of negative 3, means that as we go from left to right, for every unit we go across one, across means horizontally, that way, right? Every time we go across one, we're going to go down negative 3. So, cross 1, let's do this lightly, and then negative 3. 1, 2, 3. And we're going to end up there. Right? Same thing again. I might just move it up a little bit. Same thing again. Go across 1, go down negative 3. Go down 3. Right? 1, 2, 3. You can do it again if you like. Cross 1, go down 3. Now, what happens if you go across 2? You're going to go down 6 places, aren't you? So, 1, 2, 3, 1, 2, 3. There we go. All right. If you want, you can even draw some points. You don't have to do this many points. I'm just sort of just showing you how this actually works. If you go back 1, okay, the opposite occurs. We go up 3. So, go back 1 and then go up 3. 1, 2, 3. All right, and so on. Hopefully, the points look like they line up, and if they do, then chances are you're on the right track with it. So, just zoom out a little bit there, and I might see if I can just draw this line somewhat as neatly as I can. All right. So if you want, you can even just do it lightly in pencil. All right. Okay. You might turn around and go, if you can just see that, you think, yep, I like that. I think that's spot on. I'm happy with that. If you want, you can get a pen now and you can pen it in, okay, and that basically makes it permanent, okay. Alright. Okay. Something I haven't done and I should do, and I might do this to the first one as well. It's always useful to write the actual equation of the line near the line itself. Okay. Now I've done that kind of already because that's the title of the graph itself. But it's a good idea that to write the equation of the line. So this is the line y equals 2x minus 1, and this one I'm going to use the original form, which is 3x plus y minus 2 equals 0. It doesn't really matter as long as it's somewhere near the line and you've labeled it, then that's fine. And that's how we graph linear functions. Okay, so there's two ways: table of values, or we can actually use the characteristic of the gradient and using the y-intercept as a starting point. Okay, thanks for watching, everyone.